Okay, so yesterday we talked about a specific type of sequence. We talked about geometric sequences. And we said the big idea for geometric sequences, as I flip back, is that I'm always multiplying by something. So to find the next term, I multiply by the same number each time, and that's a geometric sequence. Today, we're going to continue talking about sequences, but we're going to see a different type of sequence today. So as I look at this sort of intro problem here, I've got three different sequences. And I want to sort of use these sequences to answer some questions. So if I take a look at sequence A, 30, 40, 50, 60, 70, what am I doing there? What's my pattern to find that next term? Yeah, I'm adding 10 each time. For sequence B, what am I doing here? 0, 5, 15, 30, 50. What am I looking at for sequence B? Could I be multiplying by the same thing each time? So I want you to look at our first term is 0. What's 0 times anything? 0. So it's not going to be multiplication, right? It's got to be some sort of addition. So how do I get from 0 to 5? Add 5. How do I get from 5 to 15? Add 10. How do I get from 15 to 30? Add 15. How do I get from 30 to 50? Add 20. So we're adding each time, but what we add changes each time. And then what about sequence C? 1, 2, 4, 8, 16. What am I doing there? Yeah, we could multiply by 2. 1 times 2 is 2, 2 times 2 is 4, 4 times 2 is 8. So using these rules that we found, I want to know the next term in each sequence. So for sequence A, sequence B, and sequence C, what's my next term? So A, we know we're adding 10 each time. So 70 plus 10 would give me 80. For B, we know that we change the number that we add each time, but that change is predictable. So I added 20 the last time. What am I going to add this next time? I'm going to add 25. So 50 plus 25 would be 75. And then for C, we know we multiply by 2 each time. So 16 times 2 would give me 32. Good. Which of these sequences fit our definition for a geometric sequence? C. Why C? Exactly. Sequence C is a geometric sequence because we multiply by the same number each time. When I multiply by the same number each time, I've got a geometric sequence. Now I want you to take a minute and find the 10th term in each of our sequences. Okay, so we found the next term. Now go out to that 10th term for sequence A, sequence B, and sequence C. Find that 10th term for me. anyone have that 10th term for sequence A? 120. How about B, sequence B? Mm-hmm. 225. And sequence C? That's almost the 9th term. $512, yeah. Which of these had our greatest value for that 10th term? Sequence C. Yeah, that multiplication, even though it started out small, grows pretty quickly. So we know that C is a geometric sequence. We multiplied by the same number each time. That's the definition of a geometric sequence. But A is another special type of sequence that we're going to focus on for today. So let's look at the sequence 2, 5, 8, blah, blah, blah. To get from 2 to 5, we can add 3. To get from 5 to 8, we can add 3. The next term in my sequence I could get by adding 3 to 8. That would get me 11. If I added 3 again, I would get 14. If we continued this pattern of adding 3, we get what's called an arithmetic sequence. So an arithmetic sequence is one in which I am adding the same term each time. I'm adding the same number each time. Okay? So for geometric, we multiplied by the same number each time. For arithmetic, we add the same number each time. That number that we add is called a rate of change or a common difference. With our geometric sequences, we used common ratio kind of more frequently than we used that other term that we had available. You could use either of these, but we'll primarily use common difference as we're working in our Unit 6 notes. So 3, positive 3 would be our common difference for this sequence. So if we take a look at our top sequences, our sequences up here at the top of the page, we know sequence C was geometric. Sequence A, we're adding 10 each time. That's arithmetic. Sequence B would be neither. I don't multiply by the same number each time, so it's definitely not geometric. It's also not arithmetic. Even though I'm adding, since I don't add the same number each time, it's not arithmetic. Okay? Sequence A is, though, since we add 10 each time. So sequence A. And our common difference is what we add each time, which would be 10. Questions for me so far? Okay, so really similar ideas to what we saw last time with our geometric sequences. This time with arithmetic, we're adding instead of multiplying. And I want you to notice here, it says that our constant, our common difference, or our rate of change can be negative, okay? So when we looked at our geometric sequences last time, we had some that were fractions. Here we thought about this pattern here is dividing by 2. Since we needed to write it as multiplication, we wrote we were multiplying by a half or 0.5. Okay. For our arithmetic sequences, it's phrased as we're always adding the same number, but subtracting is the same as adding a negative number. Okay, so if our pattern is to subtract the same number each time, that's still an arithmetic sequence. Okay, so let's take a look at some practice problems with arithmetic sequences. Similar idea to what we saw last time with our geometric sequences, right? We're going to identify that common difference and we're going to fill in the missing portions of that sequence. So as I look at A, I see I start with 1.5, and then I've got 3, and then I've got 4.5. What's our common difference here? How am I changing these each time? What do I have to add or subtract each time to get the next term? 3 plus what gives me 4.5? 1.5, yep. So our common difference is 1.5. So I can use that to fill in these blanks here. 4.5 plus 1.5 would be 6. 6 plus 1.5 is 7.5. 7.5 plus 1.5 would be 9. For B, -1, -3, -5, what's our common difference here? -2. We're actually this time subtracting 2 each time. So I'm going to say that my common difference is -2, -2. So -5 minus 2 would be -7. -7 minus 2 would be -9. How about C? 14, 13.6. What's the difference between these two? 0.4, yeah. And since my first term is bigger than my second term, we know we're subtracting, so -0.4. So 13.6 minus 0.4 would be 13.2. 13.2 minus 0.4 would give us 12.8. 12.8 minus 0.4 would give us 12.4. For D, we've got 1/5, 2/5, 3/5. What do you think the next one in this pattern is going to be? 4/5, and then 1 or 5/5, right? The same as 1. So what were we doing each time? Adding 1/5. Yep. And then our last one here. We've only got 2 terms this time, but that's okay because we know that these are arithmetic sequences. So 14 to 21. How do I get from 14 to 21? Add 7. So to get my next term, I'm going to add 7 to 21. That gives me 28. Then if I add 7 again, I would get 35. If I add 7 again, I get 42. Not too terrible? Okay. So let's take a look at the example towards the bottom of page 7. We've got some selected terms from a sequence. So I know that the first term in my sequence is 2. The second term in my sequence is 6. And then the 5th term, so we're skipping terms 3 and 4. The 5th term is 18. I have a couple of statements about this sequence, and I want to determine which of them is true. So my first statement says this sequence is geometric because each row is 3 times the previous row. Now, 2 times 3 gives me 6, and 6 times 3 gives me 18. However, are 6 and 18 adjacent in my sequence? No, they're not consecutive terms. So would it be fair to say this is a geometric sequence? No. I can multiply by 3 here, but multiplying by 3 again wouldn't give me the next term. It would give me the 5th term. So this one can't be a geometric sequence with a common ratio of 3. That doesn't fit my information here. What's more likely is that I have something that's not geometric, maybe it's arithmetic, but I have something that's not geometric because I've skipped a couple of terms there. Okay, we're going to take a look at a few more practice problems together. So if you would, for me, please turn to page 8. For number 1, we have the first 2 terms of several different arithmetic sequences. Okay, so we know these are all arithmetic sequences. That means I'm adding or subtracting the same number each time to get the next term. I want to take a look at B. B is one that we could get a little tripped up on. Remember, these are arithmetic sequences. So I have 11 and then 111. What did I add to get from 11 to 111? 100. I wanted to talk about B because this is really tempting to ignore that we've got an arithmetic sequence and just keep tacking on one digits to get the next number in my pattern. That's not what we're doing here. I want to know, what am I adding each time? We're adding 100. So my next term would be 211, and then 311, and then 411. And so for every problem for number 1, these are arithmetic sequences. You'll determine what am I adding or subtracting, and then continue that sequence. For number 2, the sequences that we're going to focus on, that we're going to give names to, are geometric sequences that we talked about last time, and arithmetic sequences that we talked about today. But not every sequence is arithmetic or geometric. If we flip back to the very start of class today, sequence B was not geometric, and it also was not arithmetic. If we go back to the very beginning of our packet, that first problem that we talked about gave us a rule, and it was 2 times the previous number minus 1. So we multiply by the same number each time. But since I also subtract 1 each time, this isn't a geometric sequence. Okay? Not geometric for that reason. So what we're going to look at with example 2 is identifying geometric versus arithmetic versus neither of those things. It's some other type of sequence. So if we take a look at A, my sequence starts with 200, then 40, then 8. So we want to ask ourselves, can I add the same thing or subtract the same thing each time to get the next term? So am I adding or subtracting the same thing to get those numbers? No. To get from 200 to 40, we'd have to subtract 160. To get from 40 to 8, we're subtracting 32. So it's not arithmetic. Could I multiply by the same thing to get each of those? Let's start with 40 and 8. What do I do to 40 to get 8? Divide by 5, or last time we talked about multiply by 1/5. If I take 200 and divide by 5, will I get 40? Yeah. So since we multiply by the same thing each time, this is geometric. Now, how about B? 2, 4, 16. Am I adding the same thing each time? No, I would add 2, and then I would have to add 12. Am I multiplying by the same thing each time? No, I would have to multiply by 2 and then multiply by 4. It looks like maybe my pattern is to square the previous number to get that next term. That's not geometric. If I have to change what I multiply by, it's not geometric. And we know it's not arithmetic because we're not adding the same thing each time. So this is neither. Neither for B. So you have a couple more sequences where you're going to do the same thing. Determine if you have an arithmetic or geometric sequence or if it's neither of those. For number 3, you're given that these are all arithmetic sequences. This is just like that example we did together a few minutes ago. Identify your common difference and fill in those missing terms. And then for number 4, you've got the same start to sequences, but one is arithmetic and the other is geometric. So fill in the next few terms if it's arithmetic or if it's geometric. Remember, arithmetic, we're adding or subtracting the same thing each time. Geometric, we're multiplying or dividing by the same thing each time. So for the rest of our class period, I want you to work on the remaining problems on page 8, and then you have one assignment on Khan Academy. Similar to last night's problem, where you extended those geometric sequences, it gave you a sequence and said, what's the next term? Same idea here, but this time they're just arithmetic sequences. So the remainder of page 8 and your Khan Academy assignment.